Have you ever wondered what the absolute greatest vulnerability in our entire global supply chain looks like? It isn't a high-tech computer chip factory, and it's not some massive trade war. It's actually just a single, narrow stretch of water. Today, we are diving into a truly terrifying geopolitical scenario that exposes this fragile choke point, and we'll be looking at an engineering megaproject so ambitious and, honestly, so utterly insane that it almost defies belief. But before we get to the $200 billion mountain-crushing solution, we really need to understand the problem. Every single day, 20 million barrels of oil flow through one tiny strip of water known as the Strait of Hormuz. Just wrap your head around that number for a second. 20 million. We aren't just talking about gasoline here. This flow is the literal foundation for fertilizers, plastics, pharmaceuticals. Virtually everything our modern world manufactures relies on this exact daily flow. So that brings us to a really uncomfortable question. What happens if it all just stops? Could the global economy actually survive a total closure of this critical choke point? And if not, what crazy lengths would humanity go to just to bypass it? The answer involves literally moving mountains. I'll explain exactly how they plan to do that in just a bit. Section 1. The most dangerous choke point, global maritime security. To understand why this is a ticking time bomb, consider this. Roughly a quarter of all global seaborne oil trade, plus 20% of the world's liquefied natural gas, is entirely dependent on this 55 to 95 kilometer wide strait tucked between Oman and Iran. If you live in a nation that relies on energy imports to keep your cities powered, this bottleneck should absolutely terrify you. Let's put this into perspective with a realistic 2026 crisis simulation. Imagine military conflict breaks out and completely halts transit through the strait. The results? Immediate and catastrophic. We're talking about stranding a fifth of the world's oil overnight and rocketing prices to a devastating $126 a barrel. This instantly sparks a global fuel crisis, forcing desperate international naval coalitions into high-stakes military action. But here's the thing. Military intervention isn't a permanent fix. Section 2. The geographic trap. Cornered exporters. This brings us to a massive geographical trap for countries heavily reliant on exporting their resources through this specific route, like Saudi Arabia and the UAE. They are physically cornered. Imagine standing at the port of Fujairah in the UAE, which is the last major port before the strait. In our crisis scenario, you'd be looking out at 180 massive vessels sitting completely paralyzed. They are going nowhere, entirely cut off from the open ocean simply because they can't cross that 133-kilometer gap. All that energy just sitting there, trapped. Now you might be thinking, well, can't they just use pipelines instead? It's a fair question, but existing alternative routes don't even come close to replacing the void. Remember, the daily oil blocked by a shutdown is 20 million barrels. The massive Saudi East-West pipeline can handle about 7 million. The UAE's pipeline? A mere 1.5 million. You simply cannot squeeze 20 million barrels of water through a garden hose. So what on earth is the alternative? Section 3. The $200 billion bypass, a permanent solution. The crucial point here is that a radical, permanent solution is needed to save global trade. We're talking about a $200 billion canal cutting directly through the Musandam Peninsula in Oman, a man-made river designed to bypass this geopolitical choke point forever. Because when you look at the geography, you realize something wild. There is only 32 kilometers of land separating the Persian Gulf from the open ocean of the Arabian Sea. That is less than the length of a marathon. So why hasn't it been built yet? Well, here is the massive problem. Think about the Panama Canal. It's 77 kilometers long, dug mostly through flat, manageable jungle, and required excavating about 74 million cubic meters of earth. The Musandam bypass might be much shorter, but carving through solid, vertical mountains means moving an absurd 400 million cubic meters of rock. That is more than 5 times the volume of the Panama Canal, and it's straight through solid stone. Section 4. An engineering nightmare, hostile and rugged. Calling this a difficult dig is the understatement of the century. This mountain range is one of the most hostile terrains on Earth. Before a single shovel even hits the dirt, just surveying the land takes a full 2 years. Why? Because the terrain is so incredibly rugged that it is completely inaccessible by land vehicles. Every single piece of equipment and every surveyor has to be flown in by helicopter. But believe it or not, the surface isn't even the scariest part. The ground itself poses a hidden, terrifying threat. These mountains are made of Hajar limestone, It's incredibly hard, but also highly fractured. Over millennia, water has carved massive, hidden underground cavities into this rock. This makes the geology incredibly unpredictable, meaning any blast could collapse an unknown cavern right out from under the crew. Parts of the mountain are literally hollow. So, how do you even navigate that? Planners looked at 3 different paths and finally settled on the 32-kilometer central route, mainly to avoid the staggering 2,000-meter high peaks up north. Even then, it still requires 3 massive lock systems to lift enormous cargo ships up and over a 650-meter elevation. But picking the route, that's just where the nightmare actually begins. Section 5. Caves, Cliffs, and Logistics. Impossible logistics. To actually carve a 300-meter-wide and 25-meter-deep canal here requires an escalation of logistics that borders on the impossible. We are talking about building a megaproject in an environment that is actively trying to destroy it. Remember those hidden caves I just mentioned? Engineers have to deploy 3,000 seismic sensors to map every single void. If they don't, the canal could accidentally breach a natural freshwater lens hidden inside the mountain, which would catastrophically flood the entire site before it's even finished. Plus, machinery has to operate on 45-degree gradients dropping straight into the sea, where one wrong move is fatal. And here is the kicker. Because there's absolutely zero existing infrastructure out there, you essentially have to build an entirely self-sufficient, high-tech city clinging to vertical cliffs just to keep your workers alive long enough to start digging. First, you have to build a massive desalination plant for 10,000 workers, then a 200-megawatt power station from scratch. Only then can you start hand-clearing and blasting 180 kilometers of cliffside access roads so the heavy machinery can even reach the site. Section 6. Is it worth the cost? Weighing the cost. So, 180 kilometers of cliff roads, 400 million cubic meters of solid limestone, and $200 billion later, we have to pull back and look at the big picture. Is a $200 billion engineering nightmare actually worth it just to bypass 32 kilometers of land? Well, consider the alternative. The complete strangulation of the global energy supply, skyrocketing inflation, and global conflict. When you weigh the enormous price tag of this impossible canal against the total collapse of the global economy, the sheer insanity of moving mountains might just be the most rational choice the world has left.